So two new functions today. Absolute value function and step function is called. Not too hard. Anybody heard of absolute value? Must have at some point.
Sometime, I don't remember what it was. Yeah.
Any thoughts on what absolute value was when you learned it?
I don't think it's this function and this
Anyway, so we've already looked at some functions, right? Like linear functions, yeah. Graph a line, yeah. Constant rate of change. And we have quadratic functions. Remember those? We didn't do too much with them, but they had an x squared in it, and they made a parabola, the U-shaped graph.
Yeah, that was fun.
Anyway, so now we have two new ones, an absolute value function and a step function. They don't do a great job of defining absolute value here, so we'll do this. Let's go to our notes page. Let me define absolute value for you. The absolute value of a number, okay, is just its distance from zero on the number line. Okay? Distance from zero on the number line.
But wouldn't that just be the number it is?
Mm-hmm.
So the absolute value of...
And that goes to like any distance in any direction from zero, right? Like positive or negative. And so the absolute value of any number
Doesn't have to be positive.
is always positive. Okay? When you do the absolute value operation on any number, the result will always be positive, whether the number was positive when it started or negative when it started. You know anything else that does that to a number, guys? Makes it positive all the time? The result? Huh?
Multiplying by a negative quantity.
Not necessarily, no. Swearing?
Sure. Oh.
Remember?
Or multiplying negative by a negative. I can't remember any.
Well, that presumes you'd have to start with a negative number, but it won't make anything positive. Anyway. And the notation looks like this. It's like, kind of like brackets, right? But they're just straight lines.
Mm-hmm.
If I write the following, see that? Just three straight lines on either side of it, and that's just red. And A is just any number you want to put in there. We can talk about some examples of numbers. You want, huh?
I was going to say any letters.
Well, no, we're going to put a number in there, but A just represents any number you want to put in, okay? This is just red, the absolute value of A.
Is that all that this is? What's that? This is
It'll be this, and then later on step functions, okay? So I said it's distance from a zero on a number line, so let me just draw a number line real quick. I'll put 0 in the middle there. And I'll go, let's see, 1, 2, 3. And -3, -2, -1. Okay? So any number you pick on that line, its absolute value is just its magnitude, like from the distance from 0. So for example, take the number 2. The absolute value of 2 is what? How far is it from 0? It's 2 units from 0, right? What about the absolute value of -2? 2. Right? It's straight distance from 0. No positive. It's just always a positive number. Okay? What's the absolute value of -3?
3.
+3. Okay? Whatever you put in between those brackets, it comes out as positive, no matter how it started. That's it. Just it's whatever it's like. See -3? How far is it from 0? 3 units, and it's just 3. It's absolute value. Okay? All right. So that's what absolute value is. I mean, you must have seen it somewhere, yeah? No?
No.
Really? Okay.
Yeah.
Okay, well, it's not that hard, though. All right, let's go back to the first page of the notes, then. So, it's basically like the size of the number, right? Does that make sense? It's the size of the number, like disregarding its sign, okay? All right, real quick here. What's the absolute value of -7?
7.
Absolute value of -2. This is so
6.
6, 0. Not brain surgery, right?
It is.
Well, then I don't want you as my brain surgeon. Okay.
You want us?
I don't, never mind. Now we're going to graph the absolute value. If the absolute value is, before we graph, let me think about this. If the absolute value, if the output is never negative, what do you think the graph might look like?
Positive?
Meaning what? Like physically, where would that graph end up being? Would they go below the x-axis ever?
No.
No, they'd always be above the x-axis, right? Unless like afterwards you subtracted 5 or something from it, right? Okay. But so we're gonna graph f of x equals the absolute value of x, okay? But so real quick here, evaluate f of negative. What does f of -7 equal if we put it in that function? 7. And what does f of 4 equal?
4.
Okay. So let's go to part B and fill out this table. We're putting each one of these in the absolute value function. So this should be simple. Just read these off. 3, 2, 1, 0. Okay? Idea? So there's our XY table. Let's graph it. So we have -3, 3, -2, 2, -1, 1, 0, 0. And like that. Where's the thing? Oh, what's that? So it goes in like that. And then this through there. Okay? Does that look a little like the parabolas we graphed before? But remember when I told you with the zero, like whenever you square something, it's positive, right? But I remember the parabola with the x squared, I said, don't make it look like a v. I said, because that's a different function altogether. Do you see the function it is now? It looks like a v.
Yeah.
It's an absolute value function, okay? All right? Okay, so that's the graph. So now let's talk about the following here. Over what domain? Remember, domain is all the what values? X values, right? So over what domain is our function, absolute value of x, increasing, going up?
0 to infinity. Positive infinity.
Right, it's all these, it's going up on this part here, this leg here, right? Here it's going down, yeah? As you read from left to right, it's going down. So every x from 0 to infinity, right?
Why do you go from B to D and not B to C?
Yeah.
Oh, I missed it. Okay, well, let's just answer this. So that domain, we could do the in-between thing, but I could just say x greater than or equal to 0. Well, at 0, it's technically not increasing, right? So I'm just going to say x greater than 0. Okay? Let's go back up and do C. What's the minimum value on this function?
0.
Okay. 0. But, like, real quick, so remember, I asked you before, where would the graph lie, right? And you said it would not go below the x-axis. Everybody see that that's the case?
Yeah.
But just a quick question. What if, in this function, I change it just a little bit? And outside the absolute brackets, I added, say, like, -2 at the end of it.
So when you go down,
So what would happen to all of these?
they would be different.
If I took the absolute value, which I did here, and then subtracted 2 from each one, what would I have?
Negative
I'd have 1, 0. I'm subtracting 2. I'm subtracting 2 from each one.
Oh. 0.
-1,
0.
-1.
So it'd be going
Negative 2. So it just shift this whole thing, the whole thing down 2, right? Wouldn't it take the whole graph and shift it down 2
Yeah,
units?
sure.
If I put minus 2 on the outside of it? Or if I put plus 5 on the outside, it would shift it which way? Oh, right, okay. All right, so these graphs can go down in the negative if it's a little more than just absolute value of x, right? Like if you subtract something outside of there. Does that make sense? Okay. I don't want you to be freaked out if you see that. All right, there's a missing thing in here. For the function, comma. Well, let me give you the function here. It's not in there for some reason.
F of 1.
F of x equals absolute value of x minus 4 inside, right? And then plus 7 on the outside. So, now keep in mind, those absolute value brackets, remember PEMDAS?
Yeah.
So in that sense, they kind of work like parentheses, right? So you got to do the stuff inside the absolute value brackets first, and then take the absolute value of it, right? Right. So they want to know the value of f of 1. So let's put that in there. Absolute value of x minus 1, and then plus 7. So let's go step by step through the order here. F of 1 equals absolute value. Well,
X minus 1.
oh, geez, God.
1 minus 4.
What's going on here?
Yeah.
All right, 1 minus 4. So it's the absolute value of what?
Negative 3.
-3. So I'm doing the work inside the brackets first, right? The plus 7 just sits out there for now. Now what do?
Correct to positive.
I take the absolute value of -3, right? So f of 1 equals what? 3 plus 7, yeah? Equals 10. Okay? So you get where the absolute value comes in now, the PEMDAS sort of operation thing? It wasn't, it was a typo that somehow it got in the conversion. PDF to Word, back to PDF, it disappeared somewhere.
Yes, change it first. Next.
Yeah, they're gonna have it easy next semester. Okay. Wait, what?
Keep going slow. What are you doing?
Ew, I hate piecewise function.
Well, you better get used to them because they're really easy and you're gonna see a crap ton. What? Don't bite.
Like I dropped
Ow.
All right. Step functions now. So they're named step functions because when you graph them, it'll kind of look like a set of steps. Yeah? So here is well, it looks like a piecewise function. I don't understand why everyone has such a hard time with these. But anyway. From yesterday, so it's got, how many pieces does this piecewise function have? 2 pieces, right? And in the first, what x values will we use the first piece for?
0 to 5.
X is from 0 to 5, including 5? No, but I might, put 5 in there, right? To see where it ends and put what kind of circle there. Open, right? And then what values of x use the second piece of the function? Every x from 5 to 10, right? By the way, remember f of x is y, yes? So this top piece, wouldn't that be y equals 2? And the bottom one would be y equals 6? What kind of lines are those? Yesterday. Yeah, what axis do they cut through? The y, and the top one cuts through the y-axis where? At 2. And the bottom one cuts the y-axis where?
6.
6. Okay? Right? Wouldn't these be horizontal lines from yesterday? You remember that? But anyway, you notice there's no x's in there, right?
Can I just go up to the line?
So you notice there's no x's in our function, right? So when I put a value of x in here, what comes out in the top part? Just a 2, because it doesn't matter what the value of x, right? It just is going to be a 2, okay? So here they want us to find some f of things here. So if our x is 0, f of 0, which one does 0 fall into, the top or the bottom?
Top.
Because that's between 0 and 5, right? So f of 0 equals what? 2. Right? Now let's take an x of 2. What is f of 2? Which one does f of 2 go into? Because it's 2 is between, right? So what does that come out as? Just a 2. F of 4. 2. F of 5.
6.
Now that goes in the bottom one, right? Now I would just say, like, I want to think, like the f of 5 for the top one would come out as 2, right? But wouldn't that be like our open circle? Remember, I wanted to see what that is, yeah? Okay, f of 7 is 6, and f of 10 is 6. Okay? That's not too hard. All right, so it's a thong after you do right down the corner. Okay, so graph the function to the right. So we have some points, 0, 2. Right? There's a point. What's our next one?
2,
2, 2.
2, 2.
3, 2. 4, we got 4, 2. And this one that didn't really belong, right? 5, 2. But what kind of a circle? 1, 2, 3, 4. What kind of a circle? Open circle, yeah? So here is my first piece. See how I put that 5 like in the one it didn't belong in? Because I want to see where it actually ends, right? What's the matter what? I just plotted these points, 0, 2. Because this particular one here, that 5, I got the 2 from here, but see, it doesn't really go in there. It actually goes to this one, and I just want to see, but even though it doesn't belong there, I want to see where the end point would be. Right? Okay, so now let's do f of actual 5, where it's supposed to go. So 5, 6, 2, 4, 5, 6. Closed circle, yeah?
Yeah.
Right? Now let's just go right out to f of 10. What is f of 10? 1, 2, 3, 4. Well, I got this wrong. Wait a minute. 1, 2, 3, 4. Yeah, I didn't go up. I miscounted. Hang on.
What are you doing? You're so
I don't know. I'm not very good at math. 1, 2, 3, 4, 5.
teacher. I don't mean he's good at it.
Yeah, I put a light on my resume. So now it's 5, 1, 2, 3, 4, 5, 6. There we go.
Wait, so open circle has to go over one then?
Well,
Say that again?
Open circle has to move over one?
Yeah, I was looking at it at an angle here. I just miscounted my grids, that's all. All right, so that was f of 5. Let's do f of 10. 6, 7, 8, 9, 10. 1, 2, I better count for short. 1, 2, 3, 4, 6, 7, 8, 9, 10. And that goes up to what? 6, closed circle. There's my step function. It's just 2 steps, right? Does it look like steps? Vaguely, come on. Like for a graph, it looks like steps.
But those look kind of.
I didn't bother because it was just,
Okay.
yeah, it was going to be included in there. When I draw that line, it includes that, right? Okay. But like, you get piecewise now,
Yeah.
that tells you which one to put your x into. That's all. It's not complicated. But that's how we make a step function. And you get why I did the open circle here.
Yeah.
The 5 doesn't really belong in that top one, but I want to know where the top one ends at, right? So I can put the open
do
circle.
you have to do that though?
Yeah, you would need, like, what else, how far would you know how to go then? You have to have that open circle here. Because, look,
Well, no, do you have to like include 5 like you did?
unless you can do it in your head, I mean, yeah. Because look, remember how, like, if you didn't have the function, you just had the graph, you can read off the values, and someone asks you, I don't know what the function is, but tell me what output x of 5 gives you, right? And if you had like a closed circle there, you'd think, oh, it gives you 2. No, that open circle means you go right through it up to there, see? Does that make sense? So you gotta have it there.
No, I was saying like in including the 5, just in general. Like, why did
Well, you
stop
do,
at
so you
4?
know where to put it, yeah. But like if you knew, I mean, you could probably in your head know that, okay, if I put 5 there, it should be an open circle without writing it over here. Is that what you mean?
No, like, why didn't you stop at 4?
Does that stop at 4, the top?
No.
So 0, 1, 2, 3, 4, 4.1, 4.2, 4.7, 4.8, 4.9, 4.99, 4.99999,
It's the reason
but not 5.
It's the reason why you put open circle on 5 is because it's not less than or greater to.
There's no equal, it's not included, right? It's where this ends. I mean, this actually ends at x of 4.999999999, right? As close as you, infinite close as you can get, right? So that really is kind of an endpoint that's not included, right? That's why. The actual output is up here. That's why I said the open circle says, oh, when I look here, I just pass through it and go to where it hits the close. Yeah, okay. Graph the step. Oh, we did it. Okay, so you get the idea there? I better get rid of that because somebody will think they'll have to put that in there. You guys are, some of the things you come up with, I don't even know why. So that's my open circle. Yeah. Okay, let's look at this next one. So this is some real world thing here. Let's read that. What kind of event are we at here?
I mean, amusement.
An
park.
amusement park. Talk to me about the money here.
3 others.
Well, read the problem. See, that you did it. You just went right to the chart. Read up on top.
A person would have to park charges the admission based on age.
There we go. Keep going.
Graph the amount of money a person would have to pay for admission based on their age. Remember that someone who is 1 day short of 4 years old considers themselves 3 and up.
You got that? Right? But how old are you? Like, when's your 16th birthday? Okay. Who's got a birthday coming soon?
Mine's in
Mine's
February.
in April.
What? Who?
Mine's in April.
Mine's February.
Yeah, mine's February.
So that's close, right? And you're how old?
16th,
All right. Just like what day in February?
24th.
So on February 23rd, you can still say you're 15 for the birth, right? Does that make sense? Okay? So I just want to clear that up. All right, so for 3 and under, right? And no, so now, what I was just talking about, that'll get you thinking about open circles, right? You see what I mean? Like up to your 16th birthday, but that day you hit 16 needs an open circle. If it's in here, does that make sense? Okay? So 3 and under is free. 8 and under is free. 16 and under is free. 17 and older, I kept saying free. 4, 8. 17 and older is $12, right?
Yeah.
So, let's see if we can graph this thing. So if this is the cost axis, wouldn't this be free down here?
Yeah.
Right? So from 0, you take a 0-year-old to the amusement park, to what? 1, 2, 3. But wait a minute. Should I have an open circle somewhere here? At 4, right? You see what I mean? Why did I put this out to 4 when it said 3?
Because you can be a day
Because until the day of your 4th birthday, they still consider you 3 in this chart. Yeah.
So, like, if you're 1, what are you going to consider as? Like,
Is 1 under 3?
yeah, but what are you going to be considered?
Oh, yeah, you're 0. Wait, if you're not 1.
Yeah.
Yeah,
They're not gonna put months on it.
right. You'd be 0 years old.
They're not gonna be able to.
Yeah. Okay. How about the next interval?
8.
8 and under. So 8 and under would go all the way down to what age? Down
0.
to what age?
4.
4. There's where a closed circle would be, right? Does that make sense? So 4, where does the closed circle go? What price?
$4.
$4. Right? And it's 8 and under, so I'm going to take this out to an open circle where?
To 8.
9.
to 9, not including 9, right? So, look, do you see this here? Everybody look up here.
Yes.
Say that's your 8th birthday, and this is your 9th birthday. All through here, you're still 8 years old, aren't you?
Yeah.
Right? And still fall under here. Does that make sense?
Yeah.
Okay. Get rid of that business there. Come on. Get out of there. Oops, there. Okay? Why don't you guys see if you can finish this out now for the other 2 ages? Okay? You get the part where the 16 and under will have an open circle where?
17.
At 17, and it'll have a closed circle where?
8.
At 8. Right? Or at 9. 9, 9, 9, 9. Yeah, sorry, 9. It'll have a closed circle at 9. Because that doesn't include 9 until you, right, get into the next category. So go ahead, see if you can finish up that graph in there. Make it look a little bit like a piecewise. What if I said that this interval is from age 0 less than 4? What if I did it like that? Right? Because like at 3 years and 11 months, like 3.9 months is still 3 years old, right? Okay, so open circle on 4. And now down here, it would start at 4, less than, including it, right? All the way up to what? Well, less than, but 9, like 8.9. So above 8, above the number 8, because after your 8th birthday, you're still 8 until you turn 9. Right? So we go to 9, but don't include your 9th day, the day of your 9th birthday. So this one would start where? But actually include it and go up to what? 17, because you're still 16 until the day of your 17th birthday, so we don't include 17.
And then 17 is 1.
And then this one would be for all x greater than or equal to 17.
17 is an arrow.
Does that help you? Like now it looks a little more piecewise, right? So our third interval is here, right? We're going to include 9. And what's the cost? $8, which is right here. And go out to what and make an open circle? 17. Right? And then our last interval
Is 12.
actually includes 17, so closed circle at what, at $12? Right? So up here to 12. So closed circle. And where does that one end?
An arrow.
Yeah, you could be 150.
I think I ever lived that long. No.
I think 130 something's like the world record. Something.
I could have a world
Who won the
record.
world record?
I don't know if you call it winning. If you saw them. Anyway, so those are step functions, okay? And they are based on piecewise. Let's go look at a couple of Regents questions. Well, yeah, aren't they pieces of different horizontal graphs? So, yeah. All right, Regents questions. This parentheses here, guys, is number 1. It goes here around the x, so there's no parenthesis at the end. Now, this one you got to think about. Remember we said absolute value is always like the minimum would be 0 because it doesn't go below the x-axis unless you tack something outside of it. So think about this one and remember what interval notation looks like with the hard bracket and the soft bracket parentheses, included, not included, right? So they want the range. The range is all what values? No, that's not me. Huh? So the range will be all the y values, the output, the graph itself, right? So what do you think? F of x equals absolute value of x plus 3, then minus 5 after you do that. Maybe if you remember absolute value, right? If that's absolute, I. This is the absolute value of X, right? What's the range of that? Just plain old absolute value of X. It's the lowest value range. Including 0 to what? Including 0 up to infinity, right? But not include, we can't include infinity ever, right? What did I tell you that, what would that -5 do with the outside? Move it which way?
Down.
How far? Because it takes all those table values, right? Wouldn't it be this? So now this is, and I'm not even worried about the +3, right? So this is the absolute value of X -5. When you do the adding and subtracting inside the function, it moves it left and right. So I'm not even worried about that. So what will be the domain of this? There are, yes. Remember hard bracket, soft bracket.
It's gonna be number 1.
Why not choice 2?
I don't know, but in the other one, with the 0, you started with the hard bracket.
Oh, that's not a reason to tell me.
Because you're including.
Well, because I included 0, right? It actually does. 0, 0 is one of the points from before. So which of these two is it? Choice 1 or choice 2? Why 1 and not 2? Yeah, because we know 5 is actually part of it, right? This means that you only go down to -4.9999999, right? So it's choice 1. Okay, so that's the range. All right, let's, here's one. Oh no, it's a piecewise. And go ahead and graph this, guys. Oh my goodness.
This one's part of the
So let's say you're going to make a table of values to graph it. What values of X will go in the top function?
-5 and 2.
Including 2? Well, you might put 2 in there just to find where you put a what? Open circle. And then what values of X go in the bottom one?
2 to 6.
Go ahead, make a table. A table. Values.
I have no wood on the table.
You know how to make a table? Can you do this? So what numbers should I include for the top part in my table? Just tell me what they are. How about -5? Keep going. -1, 0, 1. What about 2? What about 2?
Well, yeah.
I'll do it like in parentheses, right? So this will go in the top part. What values will go in the bottom one? Hannah, what X values I'm going to put in here for the bottom piece? Tell me the numbers.
2,
2.
3,
Yep.
4, 5, 6.
What about 7? No. Will there be any arrows at the ends of our graphs here? This is an important question. Will there be? No, because they told you specifically from here to there. That's it. No arrows. The arrows means it goes past that. Go ahead. Make your little table of values and graph this thing. Okay? Which one does a -5 go in, everybody? So, what's the absolute value of -5?
5.
All right, do I have to give it up? Just keep going. Yeah. So let me fill this out here. So that would be 4, 3, 2, 1, 0, 1. And that'll also be 2, right? But that's going to be my open circle. Now if I put 2 in here, that's -4 plus 10, which is 6. And that would be -6 plus 10, which is 4. Negative 8 plus 10, which is 2. Negative 10 plus 10, 0. Negative 12 plus 10, negative 2. Do you have these, Hannah?
I thought it was like,
Okay. I think you just had one, that was one quite right.
It was 4 and 2. I put it the 2 as 3 and it's
What'd you say?
I was confused
Because
because the equation
the equation was.
the equation was I was confused on that part at first because it didn't use it to the number.
Yeah, all these numbers go in that. That's kind of explicit there. So let's see, negative 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Or we know that's 2, 1, 0, 1, 1. And now there's my open circle, right? So I want a with no arrows, right? You got me there? No arrows with that? Okay? And then the other one is 2, 1, 2, 3, 4, 5, 6. Closed. Wait a minute, that's 3. Closed circle, right? And then 3, 4. Keep going like that, right? 1, 2, 3, 4, 5, and then 6. Negative 2. Like that? That. What happened? Why didn't that? This stupid thing. God. So it should be like that. Please tell me get like how to get a table of values from the piecewise now, right? It just right. You know how to get the table of values from the piecewise, right? Now, because this tells you what numbers to put in which one. This one is only for those numbers. This one is for these numbers. That's all there is to it. Okay? All right. I think that was the last reading question. Okay. Well, then you have a problem set there.